The Fageol CargoLiner was one of the most unconventional and misunderstood freight vehicles ever built in the United States, a machine that blurred the line between a truck, a semi-trailer, and an early concept of an integrated road train. Created in the late 1940s, it represented a radical attempt to rethink long-distance road transport at a time when conventional tractor-trailer combinations were already becoming dominant. Despite its technical ambition and forward-looking design, the CargoLiner was built in only a single known example, making it one of the rarest experimental heavy trucks in automotive history. The origins of the CargoLiner are closely tied to the Fageol Company, a manufacturer best known for its innovative buses and heavy-duty commercial vehicles. Fageol had long been interested in improving efficiency, stability, and driver comfort, particularly for long-haul operations. The CargoLiner concept emerged from the idea that traditional articulated trucks wasted space, added unnecessary weight, and introduced handling problems at higher speeds due to the articulation point between tractor and trailer. Fageol's solution was to eliminate the classic tractor-trailer split entirely and create a single self-propelled cargo unit. At first glance, the CargoLiner looked like a trailer that somehow moved on its own. The cab was integrated directly into the front of the cargo body, forming a continuous rectangular volume with minimal external protrusions. This design was not accidental. The vehicle was developed with aerodynamic efficiency in mind, reducing turbulence and drag compared to conventional trucks with exposed frames, separate cabs, and large gaps between tractor and trailer. While not streamlined in the aviation sense, the CargoLiner embodied a functional, industrial approach to airflow management that was far ahead of most freight vehicles of its time.
One of the most striking features of the Fageol CargoLiner was its drivetrain layout. Unlike standard trucks, which relied on a separate tractor unit pulling an unpowered trailer, the CargoLiner was fully self-propelled. The engine and drivetrain were mounted beneath the cargo floor, driving the rear axles directly. This configuration allowed the entire vehicle length to be used for cargo, maximizing usable volume while eliminating the dead space typically occupied by a tractor's frame and fifth wheel assembly. The vehicle rode on 3 axles, with a single steerable front axle and 2 rear drive axles. This configuration provided sufficient load distribution for heavy freight while maintaining acceptable maneuverability. The overall gross vehicle weight was estimated to exceed 40,000 pounds when fully loaded, with a payload capacity significantly higher than many contemporary single-unit trucks. By spreading the weight across multiple axles and eliminating the articulation joint, the CargoLiner aimed to improve stability, especially during highway cruising and braking. Power came from a diesel engine, in line with the heavy-duty transport philosophy behind the CargoLiner and consistent with information from surviving historical sources. The use of a diesel power plant emphasized torque, durability, and fuel efficiency for long-distance freight operations. While exact factory specifications are difficult to confirm due to the experimental nature of the project, the engine provided sufficient output to move the massive vehicle at sustained highway speeds. The CargoLiner was reportedly capable of cruising at approximately 55 miles per hour, a respectable figure for a heavy freight vehicle of its era, especially one carrying a full load. The integrated body was constructed using corrugated aluminum panels, a material choice that balanced strength and weight while offering resistance to corrosion. This construction method also echoed aircraft and railway freight design practices, reinforcing the CargoLiner's identity as a hybrid concept drawing inspiration from multiple transportation disciplines. The smooth, uniform sides of the cargo box emphasized the vehicle's utilitarian character and distinguished it sharply from the more visually complex shapes of conventional trucks. Access to the cargo area was provided through large side doors, allowing for efficient loading and unloading. The interior was designed as a single, uninterrupted cargo space, free from structural intrusions caused by frame rails or drivetrain components. This made the CargoLiner particularly well suited for bulky freight or palletized freight, and it foreshadowed later developments in box truck and integrated delivery vehicle design. From the driver's perspective, the CargoLiner offered both advantages and challenges. The cab forward position improved forward visibility and reduced overall vehicle length for a given cargo volume. However, the driver sat very close to the front axle, a layout that was still unusual and could feel unsettling to operators accustomed to long-nose trucks. Noise and heat management were also concerns, given the proximity of the drivetrain beneath the cargo floor and cab area. Despite its innovative engineering, the Fageol CargoLiner faced significant obstacles to widespread adoption. The most critical issue was economic rather than technical. By the time the CargoLiner was completed, the American trucking industry had already standardized around the tractor-trailer model. This configuration offered unmatched flexibility. Tractors could be swapped easily, trailers could be left at loading docks, and maintenance could be modularized. The CargoLiner, as a single integrated unit, lacked this flexibility. If the vehicle required repairs, the entire cargo system was taken out of service. Regulatory and infrastructure factors also played a role. Road regulations, axle weight limits, and length restrictions were already written with conventional trucks in mind. An unconventional vehicle like the CargoLiner did not fit neatly into existing legal categories, complicating registration, operation, and insurance. Fleet operators, always cautious about risk, had little incentive to invest in a radically different system with uncertain regulatory status. Maintenance was another challenge. While the integrated design improved cargo efficiency, it also made servicing more complex. Accessing the engine and drivetrain required more disassembly than on a traditional truck, increasing downtime and labor costs. For experimental or low-volume vehicles, these issues were manageable, but for commercial fleets operating on thin margins, they were unacceptable. As a result, the Fageol CargoLiner never progressed beyond its prototype stage. Only one complete vehicle is known to have been built, and it remained a technological curiosity rather than a production model. Over time, it faded into obscurity, remembered only in niche historical articles and rare photographs.
Yet, the CargoLiner's significance should not be underestimated. Many of its core ideas reappeared decades later in different forms. Modern integrated box trucks, cab-over-engine designs, and even certain concepts in electric delivery vehicles echo the CargoLiner's emphasis on space efficiency, modular cargo volume, and reduced structural redundancy. In this sense, the CargoLiner can be seen as a conceptual ancestor of many modern commercial vehicle designs. The Fageol CargoLiner stands as a reminder that technological progress is not always linear. Innovative ideas do not guarantee success, especially when they clash with established systems, economic realities, and regulatory frameworks. Sometimes a vehicle can be too advanced, arriving at a moment when the world is not yet ready to accommodate it. Today, the CargoLiner occupies a unique place in automotive history, not as a failure, but as a bold experiment that dared to question the fundamental assumptions of road freight transport. It remains a symbol of an era when engineers were willing to rethink the truck from the ground up, even if the result was destined to remain one of a kind.